Let's talk about electricity. You'd say you know what it is, wouldn't you? After all, you rely on it all the time. At this very moment, electrons are moving through the device you're reading this on. Electricity lights your space, preserves your food, powers and recharges your gadgets. It's all around you. So surely you understand it, right? All right, then explain it. What actually happens when you plug a device into the wall? Where does that power really originate? What is electricity fundamentally? Most people offer fuzzy answers. It's energy, it's electrons flowing, it's current in a wire. But that's the problem with those explanations. They don't truly clarify anything. They just give the mystery a different label. Yes, electrons move, but for what reason? What's actually driving them? And how does that push turn into light, heat, or motion? Here's the unsettling part. The reality is stranger than you expect. What we call electricity is deeply, fundamentally bizarre, and the way it's taught hides that strangeness almost entirely. We present it as ordinary, reliable, harmless. But once you really look, once you pull back the curtain, you see that we're harnessing something astonishing, something that quietly shatters our intuitions about how the world is supposed to work. Let me show you what I'm talking about. Try a simple experiment. Grab a piece of plastic wrap and tear off a strip. Rub it briskly between your hands, like you're trying to warm them up. Then hold it close to the back of your hand without making contact. Notice how the hairs on your arm shift, lifting, stretching toward the plastic. You can actually feel it tugging at you from a distance. Pause for a moment and really think about what just happened. You rubbed a piece of plastic, that's all. No batteries, no wires, no power source, just friction. And yet now that plastic can reach across empty space and pull on your body. How does that make sense? In everyday experience, things only push or pull when they're in contact. You move a chair, you touch it. You pick up a book, you touch it. Forces require contact. But here's the problem. That piece of plastic isn't touching you. It's pulling on the hairs on your arm through empty space. Most people just shrug. Static electricity. We covered that in middle school. No big deal. But it is a big deal. You're watching the same force that holds every atom in your body together. The force that makes chemistry work at all. The force that lets your neurons fire, your muscles move, your eyes see. This is one of the 4 fundamental forces of the universe, openly showing that it can act across distance. And you're brushing it off like a parlor trick. And this is the real issue. We've lived with electricity for so long that we've forgotten how completely unhinged it is. So let's slow down and unpack what just happened. When you rubbed that plastic, you tore electrons off your skin and stacked them onto the plastic. Just a few trillion extra electrons. And here's the part that will wreck your intuition. Those extra electrons hate being near each other. They repel one another with a force so enormous that it's almost impossible to wrap your mind around. Let me try to put numbers to it. Take 2 electrons and place them 1 centimeter apart. The electromagnetic force between them is roughly 10 to the 42nd power stronger than the gravitational force between them. That's 1 followed by 42 zeros. The difference is so vast it's almost absurd. At that scale, gravity may as well not exist. For electrons, gravity is negligible, pointless. Electromagnetic forces are what matter. So here's the puzzle. If these forces are unbelievably powerful, why isn't everything flying apart? Why doesn't matter just shred itself? The answer is almost magical. Cancellation. Think about what an atom really is. At the center, you have positively charged protons. Swirling around them are negatively charged electrons. Positive and negative, plus and minus. And these charges follow one simple rule. Like charges repel, opposites attract. The push of repulsion perfectly balances the pull of attraction. In ordinary matter, positive and negative charges are intimately mixed. Protons and electrons are packed together as tightly as physics will allow. Every positive charge is surrounded by negatives, every negative surrounded by positives, and they perfectly balance. The enormous repulsive forces are exactly cancelled by equally enormous attractive forces. Everything ends up neutral. The forces haven't disappeared. Those immense electromagnetic forces are still at work, but they're so precisely balanced that on the whole their effect is zero. And because these forces are so unbelievably strong, even the tiniest imbalance produces effects you can actually feel. When you rub that plastic wrap, you might shift just 1 electron in a trillion. Practically nothing, but it's enough to make your arm hairs rise. When the underlying forces are that enormous, even the smallest excess becomes instantly noticeable. This changes everything you thought you knew about matter. Pick up a mug, hold it in your hand. What do you think you're feeling? The solid ceramic, not even close. What you're really feeling is electromagnetic repulsion. The electrons in your hand are fiercely pushing against the electrons in the mug. You can't push your hand through it because those forces are so immense that the electrons simply won't let each other occupy the same space. Your hand never truly touches the mug. There's always a tiny gap between the atoms in your hand and the atoms in the mug. You're not feeling physical contact. You're feeling the electromagnetic force pushing back. And here's the part that should completely shift how you see the world. Every force you've ever felt is electromagnetic. Every push, every pull, every sensation of touch, pressure, or resistance. It's all the result of electromagnetic attraction and repulsion acting across space, and you've never actually touched anything in your entire life. Every time you think you make contact, what you're really feeling is electrons pushing against other electrons across empty space. It's the same force you saw with the plastic wrap, just operating at much smaller distances, where that force becomes overwhelming. Now let's talk about wires. Imagine a copper wire running through your house. One end is plugged into an outlet, the other end is connected to a lamp. You flip the switch and the lamp lights up instantly. What just happened? The usual explanation compares electricity to water. Electrons enter one end of the wire, flow through it, and exit the other end. That story? Completely wrong. Electrons in a wire move incredibly slowly, about 1 millimeter per second. At that rate, it would take nearly half an hour for a single electron to travel across your house. And yet, the lamp lights up instantly. So what's really going on? Here's the secret. The wire is already packed with electrons. Copper is full of free electrons just waiting to move. When you flip the switch, you create a voltage difference. That voltage pushes on the electrons at one end, and because electrons repel each other across space, that push is instantly transmitted down the line. One electron pushes the next, which pushes the next, and so on, all the way to the lamp. And it's like a row of people standing shoulder to shoulder. If you nudge the person at one end, the person at the other end feels it almost instantly, not because the first person walked down the line, but because the push traveled through the crowd. In a wire, the push moves at nearly the speed of light, not because the electrons themselves are racing along, but because the electromagnetic force transmits the push across distance almost immediately. That's what makes electricity so powerful. You can push in one place and something responds almost instantly, even across vast distances. But where does that push actually come from? Let's follow it back. Your lamp is plugged into an outlet, which is connected to the wires in your walls. Those wires lead to power lines, which stretch all the way to a power plant, maybe miles away, maybe 100 miles away. And at that power plant, something is turning. A massive turbine, weighing tons, spinning at thousands of revolutions per minute. That distant mechanical motion is what ultimately powers your lamp. How does that work? The link between that spinning turbine and your lamp is magnetism. Electricity and magnetism aren't separate. They're two sides of the same coin, different expressions of a single unified force, the electromagnetic force. Moving electric charges generate magnetic fields, and changing magnetic fields produce electric currents. You can't have one without the other. They're inseparable. Here's how a generator does its magic. You rotate copper wire inside a magnetic field. The magnetic field exerts a force on the electrons in the copper. The electrons resist, but the field keeps pushing. Eventually, they start to move. That movement is electric current. That's all there is to it. Motion, magnets, and copper combine, and you get electricity. Now run it in reverse. Send electricity through copper wire inside a magnetic field. The field pushes on the moving electrons, and the wire starts to move. That's a motor. Same principle, just flipped. Generators convert motion into electricity, while motors convert electricity into motion. And the reason this works is that electricity and magnetism aren't separate. They're two expressions of the same fundamental force. This should feel impossible. You're saying I can move metal here and other metal moves somewhere else with nothing physically connecting them except a thin copper wire? Yes. You're saying that spinning a magnet near copper creates a push that travels through wires and makes other copper move? Yes. And we rely on this every single second of every day. Every motor, every generator, every power grid on the planet works exactly this way. Water pours down one side of a dam, turbines begin to spin, copper wire moves through magnetic fields, electrons are pushed. That push races through hundreds of miles of wire at nearly the speed of light. It arrives at your house, sets electrons in motion through a motor, and your fan starts to spin. Water falling in one location makes a motor turn somewhere else, miles away, connected by nothing more than thin metal wire. That's absolutely mind-blowing. You don't even need permanent magnets for this to happen. Take a coil of copper wire and run electricity through it. The moving electrons generate a magnetic field. Now place that coil near another coil of copper. The changing magnetic field pushes on the electrons in the second coil, creating a current, even though there's no physical connection. That's a transformer. That's how the power grid functions. Just copper, just motion. That's all it takes. Metal communicating with metal across empty space through electromagnetic fields. Now here's the part that should completely shift your perspective on reality. I mentioned earlier that every force you feel, every push, every pull, every touch, every pressure is electromagnetic. But think about what that really means. The forces you experience in daily life, the so-called normal mechanical forces, aren't fundamental at all. They're just consequences of the electromagnetic force. Electromagnetism is the underlying reality. Everything else emerges from it. When you push a door, what's really happening is electromagnetic repulsion between the electrons in your hand and the electrons in the door. When you walk across the floor, you're supported by electromagnetic repulsion between the electrons in your feet and those in the ground beneath you. When light enters your eyes, you're sensing oscillating electromagnetic fields that set electrons in your retina in motion. It's all electromagnetic. Chemistry is nothing more than electromagnetic interactions between electrons and atoms. Heat is atoms vibrating while electromagnetic forces bind them together. Biology is built on chemistry, which means it's built on electromagnetism. Your entire sensory experience of reality is the result of electromagnetic interactions. And here's the deepest point of all. You can't explain the electromagnetic force using anything more basic. You can't say it's like a spring or a rope, because springs and ropes only work because of electromagnetic forces. Electromagnetism is fundamental. It's one of the four core forces of nature. At some level, you have to accept it as a raw fact about reality, and then use it to explain everything else. That idea is uncomfortable because electromagnetic forces act across space, and that clashes with your instincts. You evolved to make sense of contact forces, but contact itself is an illusion. There is no true touching, only electromagnetic forces acting across extremely small distances. To truly understand electricity, you have to reconstruct your intuition from the ground up. You have to accept that the universe is made of fields filling all of space, that charged particles push and pull on one another through those fields. That action across distance isn't unusual. It's the fundamental rule. When you flip a light switch, here's what's really happening. You close a circuit. Electrons throughout the wire begin to drift slowly, moving about a millimeter per second. Back at the power plant, a turbine spins. Magnets rotate near copper coils. The changing magnetic field pushes electrons. Those electrons push on the next ones, and the push travels at nearly the speed of light through hundreds of miles of wire. The push reaches your home. Electrons flow through the thin filament. The filament resists, making it difficult for electrons to pass. That resistance produces heat. The filament gets hot enough to glow white. Electromagnetic waves radiate outward. Some of those waves strike your eyes. The oscillating electromagnetic fields move electrons in your retina, triggering chemical reactions. Signals travel through your neurons to your brain, and you see light. Every step of the process is electromagnetic. The spinning turbine, electromagnetic forces, the signal racing down the wire, electrons pushing each other through electromagnetic repulsion, the filament resisting the flow, electromagnetic forces at work, the glowing light, electromagnetic waves, and your perception of it, that's electromagnetic too. Consider how remarkable this is. Just 200 years ago, none of this existed. Then we discovered these forces. We learned how to control them. We created machines that could generate electricity, send it across vast distances, and harness it to perform work. In doing so, we utterly transformed human civilization. Electricity gave us instant communication, telegraph, telephone, radio, television, the internet, all made possible by electromagnetic forces. It gave us artificial light, turning cities into places that never sleep. It gave us motors, machines that can perform work without relying on human or animal strength. It gave us computation, billions of tiny switches controlling electromagnetic forces to process information. Everything, every part of modern life runs on electricity, and it all comes from a single insight. There's a fundamental force that acts across space. Learn to control that force, and you can achieve things that would seem like pure magic to someone from 200 years ago. So what is electricity really? Electricity isn't a thing you can hold. It's not a substance or a fluid. Electricity is what we call the process of using the electromagnetic force to do work. But at a deeper level, electricity reveals that the world isn't what it appears to be. The world seems solid, mechanical, with objects pushing and touching each other. That's an illusion. The true reality is made of fields and forces acting across space, particles pushing and pulling on one another through empty space. When you watch plastic pull bits of paper toward it, you're witnessing the same fundamental force that makes chemistry possible. When you flip on a light, you're directing electromagnetic fields that fill all of space. And once you truly grasp that, once it really sinks in, everything shifts. You start to see that the world is electric, that forces act across distance, and that solid matter is nothing more than a finely balanced dance of attraction and repulsion. And you realize that humans uncovered this. We identified these forces, learned how to control them, and built an entire civilization on their backs. That stands as one of the greatest achievements of human intelligence. So the next time you flip a switch, remember, you're not just turning on a light, you're commanding fundamental forces. You're making electrons push on one another across entire cities. You're turning motion into electromagnetic fields and back into motion again. You're exercising power over nature itself. And that's what electricity truly is. Not just a utility, not merely a convenience, but a window into the deepest structure of reality and proof that humans can understand it and shape it. That's the real story of electricity. Not comfort, not familiarity, just truth.